Okay, we now have our last two gas laws that we're going to deal with in this chapter. Dalton's law of partial pressure is 1, and the formula is the total pressure of a container due to the gases within will equal the pressure of the first gas plus the pressure of the second gas plus ... however many different types of gases you have. The other gas law is Graham's law, which is a rate of effusion, which means how fast does a gas escape from a small hole within a container. And the formula is the rate of A divided by the rate of B equals the molar mass of B divided by the molar mass of A. So you can compare one gas's ability to escape as compared to another. Okay, let's look at the first problem. It says that you have 696 milliliters of hydrogen gas and 833 milliliters of helium gas. Both are at a temperature of 35 degrees Celsius and the pressure of 70.8 kPa. They are both injected into the same container, which is 409 milliliters. What is the pressure that those two gases are applying to that container, assuming that there's no change in temperature? Well, you are going to have to find out what the change is in pressure from the volume going from 696 to 409, and you're going to have to calculate the change in pressure from a volume of 833 to 409 and then add them together. So let's try doing that. First of all, how does the pressure change in the first situation? Well, they were both at 70.8 kPa. We need to multiply them by a volume ratio which would indicate the direction of pressure. So this typically is an example of Boyle's law, and the volume actually went down from 696 to 409, so that means the pressure needs to go up. So we're going to set up that volume ratio so that the higher number's in the top, which is 696, and the lower number in the denominator, and that way when we do our math the pressure will increase, and it does. We're going to say it goes to 120.5 kPa. That's the first gas. That's the hydrogen gas. The second gas, helium, went from 833 to 409. So the volume went down with that one again, which means the pressure needs to go up once again. So we're going to start with 70.8. We're going to set up our ratio to make that pressure go up. So we're going to put the 833 in the numerator and the 409 in the denominator, and that ends up being 144.2 kPa. Now we're going to add those together, and our value comes out to be 264.7 kPa. And since this is in 3 sig figs, we should probably have our answer in 3. So our answer is 265 kPa. Perfect. Okay. Now that happened to be an example of Dalton's law. Pressure of 1 plus the pressure of 2 equals the total pressure. Okay, problem 2 says, what is the ratio of the rate of effusion of ethane, C2H6, to that of ammonia, NH3, at the same temperature? It's asking us to express our answer in 3 significant figures. So we would say that the rate of C2H6 over the rate of ammonia is equal to the square root of the molar mass of ammonia, which is 17.0 grams per mole, divided by the square root of the ethane, and that molar mass is 30 grams. The square root of 17 is 4.12, And the square root of 30 is 5.48. So our answer is 0.752. And that makes sense that ethane would effuse out of a container slower than ammonia because it does have the higher molar mass. Ammonia is only 17 grams, whereas ethane is 30.0 grams. So it will effuse slower than ammonia. Okay, I think we probably know how to do these problems. 3 and 4 are basically the same as 1 and 2. The answer you should get for number 3 is 129 kPas. So let's see if you can get that. And the answer for number 4 is 1.27 times faster. Okay, good luck.